Hello everyone, welcome to Neetshala Organic Chemistry Revision Lecture Series. In this lecture, we will be taking the chapter Aldehydes, Ketones and Carboxylic Acid. Now, in the previous chapter, you have studied about alcohols, phenols and ethers. In all those compounds, you have seen that the carbon is attached to oxygen by means of a sigma bond. Now, if we take the compounds aldehydes, ketones and carboxylic acid, you have carbon attached to the oxygen by means of a double bond, one sigma and one pi bond. So that is the difference between these two. And these compounds are commonly called as carbonyl compounds. So let's get started with the chapter. First, we will study about the structure of the carbonyl group. First important point is that the carbon-carbon bond, the carbonyl carbon atom is sp2 hybridized. That is the first important point. And how many sigma bonds are there? There are 3 sigma bonds, as you can see, 1, 2 and 3. 3 sigma bonds will be there and 1 pi bond will be formed between the carbon and oxygen atom. So what will be the hybridization? Hybridization is coming out to be sp2, and if it is sp2, it is 120 degree. 120 degree is coming out to be the bond angle, and you can see all are lying in the plane, right? All are lying in the plane, so we can say it is trigonal coplanar in structure. Now if we take the compound, we can see that oxygen is present and this oxygen is highly electronegative. Since the oxygen is highly electronegative, it will try to pull away the electrons from the double bond like this. So there is a possibility that the oxygen will get a negative sign and carbon will get a positive sign. So we can say it is a polar bond. That is an important point. It is a polar bond. And this oxygen, it is ready to form a negative sign. So we can say this oxygen is a nucleophilic center. And what about the other one? The carbon is coming out to be the electrophilic center. So that is an important point. Oxygen is acting as a nucleophilic center and carbon is acting as an electrophilic center, or the Lewis acid. Let us now talk about the general methods of preparation of aldehydes and ketones. First one, by the oxidation of alcohols. This you have already discussed in the previous chapter. How to do? If we have a primary alcohol will give us aldehyde. It will give us aldehyde, and secondary alcohol will give ketones. This is what you have studied. Second process is dehydrogenation of alcohols. Now how can you carry out dehydrogenation? By using copper. You can use dehydrogenation. That is nothing but removal of hydrogen or oxidation itself. So the same process is going to happen. The primary is going to convert into aldehyde and secondary is going to convert into ketone. Now from hydrocarbons, how can you prepare? The first one is ozonolysis. So if I have an alkene, I can prepare aldehydes by using the method of ozonolysis. So we have already studied about ozonolysis. Let's just recap that here. If I have a compound like CH3, CH, double bond CH2, what I should do? Write an oxygen above the double bond, write an oxygen under this carbon, write an oxygen under this carbon, join these two, form an ozonide, and then break from the roof to the base, and whatever is left you have to join to get the compound. So this is CH3CHO, and this we will write it as HCHO, methanol, and this one is ethanol. So this is what is known as ozonolysis. Now how to prepare aldehydes and ketones from alkyne? So it is CH3 C triple bond CH, right? We have to add water to it in the presence of Hg2 plus and H2SO4. Okay, so at that time what happens is that there is Markovnikov's addition. So this side is deficit of hydrogen, right? We have to make the poorer. So we have to add the OH group here, and we have to break the triple bond and make it a double bond. To this side we will add hydrogen because this is excess in hydrogen, so we will add more hydrogen to that. We have to make the richer. So we will be getting CH3 COH double bond CH2 as the compound, right? So this is what we have got over here. Now This one can be arranged, or we can say rearranged. What is the rearrangement? Let us bring, I'll take another color. Let us bring this double bond over here, and this oxygen let us give to the carbon. This is nothing but ketoenol tautomerism. This is the enol form. How can I say it is the enol form? I can see a double bond here, right? So en, and we have an OH here, all. So we have enol, right? Now how to convert it into keto form? You have to shift the double bond to the carbon that is here, and the hydrogen on the oxygen should be given to the other carbon, that is like this. And now what am I getting? I will get CH3, C double bond O, single bond CH3. So I got a ketone here. So this is the another method of preparation from alkyne. So we have completed this topic, general methods of preparation of aldehydes and ketones. So this is easy, right? And in this, most important one is this ozonolysis and hydration of alkynes. This one is very important, so I will put a 2 star for this, and I will put a 3 star for this. Very important reactions. You can expect one among these for the exam. Let us now talk about, so I'll just clear this slide. Okay, so let us move on to the general methods of preparation of aldehydes. Now, this chapter is very famous chapter. What is the reason? It has so many named reactions in it. So many named reactions are present in this chapter. So how to deal with named reactions? There is only one way to deal with it. Make a chart. Make a chart of named reactions where you will have one column for the reactant, another column for the product, another column for the reagent that is used, and also you have to specify the name. If there is any limitation, you can specify that also in a separate column. So if you learn like that, it is easy for you to understand what is converted to what. That is the most important thing that is asked from a named reaction. And if you have downloaded the revision book, we have uploaded a revision book in the Neetshala app, in which you can get all the named reactions together in the form of a table. So if you have not downloaded that, you can go to Neetshala app, you can go to the concept booster series, concept booster notes, chemistry. So you can download the note from there. Let us now talk about preparation of aldehydes. So when we talk about the preparation of aldehydes, the first one is from acyl chloride. Now what is acyl chloride? General formula is RCOCl, that is acyl chloride, or we can have benzene with a COCl, that is known as acyl chloride. So that is now treated with hydrogen in the presence of palladium and barium sulfate or quinoline. This is known as Rosen-Mundt reaction. What is happening is that this Cl is going to be removed and hydrogen should be placed over here. So that is why we are getting benzaldehyde over here. Okay, this is Rosen-Mundt reduction. So we have to study what is the catalyst which is used for this particular process. It can be palladium or barium sulfate, and we have to add hydrogen, right? It is addition of hydrogen, that means it is reduction, right? Chlorine is substituted by hydrogen, it is reduction reaction. Let us now talk about second method, that is from nitriles and esters. This is important. So many reactions are coming, so this is important. What are we going to do? First one, we are going to treat the nitrile, that is RCN, with SnCl2 and HCl. This is again a reducing agent. Okay, SnCl2 plus HCl is a reducing agent. So when we are treating RCN with SnCl2 and HCl, we will be getting RCH double bond NH. This compound is known as imine. This is known as imine. Okay, compound where there is carbon double bond nitrogen, that is known as, this type of compounds are known as imine. Now this imine on hydrolysis, what will you get? This on hydrolysis will give us the corresponding aldehyde. Okay, so this reaction is known as Stephan reduction. So in Stephan reduction, you will use SnCl2 and HCl. RCN is converted to RCHO. Let us now talk about the next reaction. What is the next reaction? The next reaction is treating with Dibal H. What is Dibal H? Diisobutyl aluminium hydride. Diisobutyl aluminium hydride or Dibal H. Either you can write it as Dibal H, or you can write it like this. This is another method of representing. So what is happening? RCN is converted to RCHO, and here you have an ester, right? RCOOR dash, that is an ester. So that can be also converted into a corresponding aldehyde, right? This much group will be converted to an aldehyde. This much will be removed and that will become an alcohol, and the other part we will add a hydrogen and we will get a corresponding aldehyde over there. So that is about the preparation of aldehydes from nitriles and esters. So let's remove this blank slide, and here we go. Third method, from hydrocarbons. So when we talk about hydrocarbons, we are mainly focusing on aromatic. We can do it for our aliphatic also, but mainly we are discussing about aromatic here. First one, we are taking toluene. Toluene is treated with CrO2Cl2. CrO2Cl2. What is that? Chromyl chloride, right? We are treating it with chromyl chloride in the presence of a low polarity solvent such as CS2, carbon disulfide medium. We get a complex like this, and this complex on hydrolysis will give us benzaldehyde. This reaction is known as Itard reaction, another named reaction. We studied Rosenmund reduction, then we discussed Stephan reduction, and now we are discussing Itard reaction over here. Let us now talk about the next one, that is use of chromic oxide. So if you have toluene, you can convert it into benzaldehyde either by using chromyl chloride, this one was chromyl chloride, and or you can use this compound, that is CrO3. CrO3 can also be used, or you can use side chain chlorination followed by hydrolysis. What is side chain chlorination? We are treating this with Cl2/H nu. Cl2/H nu is there. Now somebody may be asking that can I substitute the chlorine directly on the benzene ring? No, because we need a Lewis acid over there, right? And hydrous AlCl3 should be there if we have to substitute it on the benzene ring. So here we have Cl2/H nu. So it is going to replace the hydrogen from the methyl group. So it will form CHCl2, two times of chlorination we are conducting. So we will be getting this compound, benzyl chloride here. Now this benzyl chloride on hydrolysis will give us benzaldehyde. So this is another method of preparation from toluene. So from toluene you can prepare by three means. Either we can use chromyl chloride CrO2Cl2, or we can use chromic oxide CrO3, or we can carry out side chain chlorination and you can carry out the hydrolysis after that. Let us now talk about the Gattermann-Koch reaction. Now what is Gattermann-Koch reaction? In Gattermann-Koch reaction, you're taking benzene, okay? You're taking benzene, you have to treat it with CO, HCl, CO and HCl, carbon monoxide and HCl. Okay, you need an acidic medium here, and we are also using anhydrous AlCl3 and CuCl. Okay, so we are getting benzaldehyde over here. Now look here, this one has 6 carbon, but this one has 7 carbon. So it is an ascent of series, right? This is the first ascent of series that we have studied. Ascent of series. Now earlier we have studied one reaction, this one. This is a descent of series. Why is it a descent of series? Because this one has, here it is 10, 11, 13 carbon was there, but here it has only 11 carbon, right? So it is a descent of series. So now let us move on to the preparation of ketones. So when we talk about the preparation of ketones, the first one is from acyl chloride. So acyl chloride is treated with R2CD. Now what is R2CD? Dialkyl cadmium. Dialkyl cadmium. So if we treat it with dialkyl cadmium, we will be getting a ketone. How? CdCl2 is removed. You have to take two molecules of this one. I will take a reaction. R C double bond OCl. This is acyl chloride. This have to be treated with CdCl2. So I have to take two molecules. So this Cl and this Cl I can remove along with, we have R2CD and we have RCOCl, right? So it is R2CD. So this cadmium is going to take up these two chlorine and moving out as CdCl2, and whatever is left, this chlorine is left, this much is part is moving, and this R2 we are going to add over here. One R will come over here and another R will come over here. We will get two molecules of ketone over here. That is the reaction that is happening. Now from nitriles also we can prepare by treating it with Grignard reagent. So again Grignard reagent is coming over here. We have nitrile treated with C6H5 MgBr. What is happening? We have to attach the NMgBr. Okay, NMgBr is coming over here, and C6H5 we have to attach to the carbon, right? So now this is hydrolyzed to give us this compound. Okay, so it's a very easy reaction. We have already studied how to deal with Grignard reagent. Let us now talk about method of preparation of ketone from benzene. Now how to prepare it from benzene or substituted benzene. Whenever we have benzene or substituted benzene, it is treated with acid chloride in the presence of anhydrous aluminum chloride, that is RCOCl plus AlCl3. So that time also we will be getting this compound over here. So this is basically our Friedel-Crafts acylation reaction, right? It is also known as Friedel-Crafts acylation reaction. Let us now talk about the physical properties of aldehydes and ketones. Now here first point is regarding the state. Methanol is a gas at room temperature. I'll just zoom this page. I hope this is clear for you now. Methanol is a gas at room temperature. Ethanol is a volatile liquid. Other aldehydes and ketones are liquid or solid at room temperature. Now, if I take the boiling point of aldehydes and ketones are higher than the hydrocarbons and ethers of comparable molecular masses. What is the reason? Reason is because of the weak molecular association in aldehydes and ketones, that is due to dipole-dipole interactions. Also, the boiling point is lower than alcohols. What is the reason? Reason is because of the absence of intermolecular hydrogen bonding. Okay, so this is some of the important point to note over here. Now if I take the next paragraph, here you can see that the lower members are miscible in water. This is important. Lower members are miscible, their size is less, so they can break the bond and they can form hydrogen bonds over here, and they are miscible in water. Whereas the higher elements, they are not miscible. Now, the solubility of aldehydes and ketones decreases rapidly on increasing the length of the alkyl chain. All aldehydes and ketones are fairly soluble in organic solvents such as benzene, ether, methanol, chloroform, etc. Lower aldehydes have sharp, pungent odors. They have a very foul smell. As the size of the molecule increases, what happens is that the odor becomes less pungent and more fragrant. Right? We have seen that aldehydes have a usually it have a sweet smell, but lower elements have a pungent smell. Okay, so that is why it is used in perfumes and flavoring agents like vanilla flavor, right? Vanilla is basically an example for aldehyde. Okay, so that is the important point to note over here. Let us now talk about the next reaction. The first one is reduction reaction. So when we talk about reduction reaction, first one is reduction to alcohols, which we have already discussed. We can use either sodium borohydrate NaBH4, or we can use lithium aluminum hydride, that is LaAlH4, or we can also use LaH. Or we can carry out catalytic hydrogenation, that is hydrogen in the presence of platinum. All these can be used for this conversion. We have already studied this in the previous chapter. This also we have studied. Reduction to hydrocarbons. If we have carbonyl compound and if I treat it with zinc amalgam and HCl, we get CH2. This is Clemmensen reduction. If I have carbonyl compound treated with hydrazine in the presence of KOH, that is basic medium, I will be getting Wolff-Kishner reduction. And these has some exceptions. Here we can see HCl. So it is acid, right? So if there is any acid sensitive groups which is present in the compound, then it will misguide the reaction. So that is the disadvantage of Clemmensen reduction. And Wolff-Kishner reduction is not undergone by base sensitive groups. So this is important. We have discussed in detail of these two topics and the limitations in the chapter of alkenes. Okay, so let us now talk about oxidation. Now reduction we have studied. Reduction will give us alcohol. And now we are going to discuss about oxidation here. Now how oxidation is carried out? Okay, here you can see if I have an aldehyde, it will undergo oxidation to form RCOOH. Whereas if I have a ketone, I will be getting a mixture of carboxylic acids over there. This is the most important point. Now let us see the different tests. First one is tolerance test. It can be used to distinguish between aldehydes and ketones. Okay, tolerance test means what is happening, we are treating aldehyde. Remember that we are treating aldehyde. Okay, aldehyde is treated with freshly prepared ammoniacal silver nitrate solution. Ammoniacal silver nitrate solution means this AgNH3 twice plus. This is the formula of ammoniacal silver nitrate solution, that is known as tolerance reagent. So when we are treating with that, what is happening, RCHO is converted into RCOO minus, that is the oxidized product. This compound will dissociate to form ammonia, and also you can see a silver mirror here, right? This is silver mirror because of the deposition of silver at the bottom. So this is known as silver mirror test. Tolerance test is also known as silver mirror test. Now the most important point is that this reaction is carried out in alkaline medium. So that is the important point, alkaline medium. Next, Fellings test. What happens in Fellings test? We have two solutions, Fellings A and Fellings B. What is Fellings A? Fellings A is copper sulfate and Fellings B is alkaline sodium potassium tartarate, also known as Rochelle salt. These two solutions are first mixed. Okay, these two solutions are well mixed, and if we are carrying out the reaction and getting a positive result, we are expecting it to have a red precipitate. This is important. We'll get a red precipitate over there. What is the reason for that red brown precipitate? It is because Cu2O is settling at the bottom. Cu2O is settling at the bottom as the precipitate, and that is the reason for the reddish color over here. So here we have Cu2 plus and RCHO is again converted to RCOO minus. Now most important thing is aromatic aldehydes. Aromatic aldehydes will not give this test. This is important. Aromatic aldehydes will not give this test. That is also important. Ketones and aromatic aldehydes will not give. Only aliphatic aldehydes will give us Fellings test. So that is a very important point. Next, let us talk about next reaction, that is haloform reaction. Now in haloform reaction, what is happening? We are treating methylated ketone. It's very important. We have to take methylated ketone. Methylated ketone means it is having a general formula RCO. Here we do not need any other group. We need CH3 alone, right? So this group will be moving out as CH3. We are treating it with halogen. If I'm treating it with iodine, it is iodoform reaction. So we will be getting CH3 and the remaining compound is going to form a sodium salt. This is the reaction and it will form a yellow precipitate. It will form a yellow precipitate as you can see over here. So this yellow precipitate indicates positive result for a haloform reaction, right? So haloform reaction condition is important. It needs methyl ketones. Methyl ketones. Because we need alpha hydrogen, that is the reason. Let us now talk about the next very important reaction, that is aldol condensation. I will teach it with the help of a simple trick. If I take a molecule CH3 CHO and another molecule of CH3 CHO, do I have alpha hydrogen in both? Yes. Always remember, aldol condensation happens in those compounds where alpha hydrogen is present. This is very important. Okay, so what am I going to do? This is the carbonyl carbon. From the carbon adjacent to the carbonyl carbon, I am going to take out one hydrogen, and I am going to attach that on the oxygen. This is not mechanism, this is a trick. Okay, from the carbon adjacent to the carbonyl carbon, we have to take out a hydrogen and we have to substitute on the oxygen. And now you have to write it as a single molecule. What am I getting now? CH3, CHOH, CH2, right? We have removed a hydrogen, so we are left with CH2 and we have a CHO, right? Now what is this compound? This is our alpha carbon, this is our beta carbon. So it is beta hydroxyaldehyde, right? It is beta hydroxyaldehyde. This beta hydroxyaldehyde is known as aldol. This is known as aldol. Okay. Now this compound I can also write it as this. So if I am heating this compound, what is happening? These two molecules are going to move out. Elimination of water is going to happen, and we will be getting CH3, CH, double bond CH, single bond CHO. This is what we are getting in aldol condensation reaction. Now always remember the reagent also. Reagent used is dilute NaOH. Dilute NaOH is used for carrying out aldol condensation reaction. Let us now take another example. CH3, CH2, CHO plus CH3, CH2, CHO. So this is the carbon, this is our alpha carbon. So take out one of the alpha hydrogen and substitute over here. So we will be getting CH3, CH2, CH with an OH. Next we have to write this CH. Onto that CH we have to attach this CH3 and CHO. That is important. Okay, and now we have to remove this hydrogen and OH. We have to join these two with the help of a double bond. So we will be getting this compound over here. You can arrange it and you will get a compound. That means you have to put the CH3 over here. If you arrange it as a straight chain compound, put a CH3 over here, and straight to this carbon you can put a CHO. This is the product that you're getting. So this is the trick for doing this type of problems. Now, what about cross aldol condensation? In cross aldol condensation, I am taking two different aldehydes. Okay, aldehydes or ketones we can take. The same process is going to happen for ketones as well. Now what is going to happen is that first I will be getting the self aldol condensation product of this as my product A. Next I will get a product B, which is a self aldol condensation product of CH3, CH2, CHO. Next is a cross aldol, taking this molecule as the first molecule and this as the second molecule, and that is our C. So C is 1, 2 and D is formed if I consider this as my first molecule and this as my second molecule. So let us take it as 2, 1. We have to do the condensation like that. So we will get 4 products over here. This process is cross aldol condensation. So here is a DIY for you. Try out the cross aldol condensation of CH3CHO and CH3CH2CHO and comment the 4 products below. Use the trick above and comment the products below. Okay, so let us talk about the next reaction, that is Cannizzaro reaction. Now, Cannizzaro reaction is important. This is carried out by those where alpha hydrogen is absent. So here you can see formaldehyde and benzaldehyde. In both these compounds, alpha hydrogen is absent. So in those compounds, we are treating it with concentrated KOH. Earlier we used dilute NaOH or KOH for aldol condensation. Here we do not need alpha hydrogen, and here we are taking concentrated KOH over here. We will be getting an alcohol, so that is important. First product is an alcohol and second product is sodium or potassium salt of carboxylic acid. Okay, so that is about this reaction, that is Cannizzaro reaction. Let us now talk about electrophilic substitution reaction. In electrophilic substitution reaction, what is happening? We have an aromatic aldehydes and ketones. This CHO group is meta-directing. Remember that. It is deactivating group. So it is meta-directing group. So it will always give us meta products in all types of electrophilic substitution reaction. That is the important point. Now, it does not undergo Friedel-Crafts reaction. You have to find out the reason. Comment below what is the reason why electrophilic substitution reaction is not given by aldehyde. Friedel-Crafts reaction. Friedel-Crafts alkylation and acylation is not given by aldehydes and ketones. What is the reason? You have to comment below. Try it, find it out and comment below. Let us now talk about carboxylic acids. Now, when we talk about carboxylic acids, again we can say that there is a carbon double bond oxygen and also we have a carbon single bond oxygen. Both are present over here. And what is the bond angle? The bond angle between them is 120 degree. Again, it is the same, 120 degree. So that is an easy topic. Let us now move on to the methods of preparation. Methods of preparation. First one is from primary alcohols and aldehydes. So how can we prepare it from primary alcohols and aldehydes? From alcohols, if I have to treat, I need to treat it with a strong oxidizing agent. Strong oxidizing agents includes potassium permanganate, CrO3, that is known as CrO3 in the presence of H2SO4, that is known as John's reagent, or we can use potassium dichromate. These are the strong oxidizing agents. So we will be getting acids over there. Let us now talk about alkyl benzenes. So whatever be the alkyl group that is converted to an acid if I treat it with KMnO4 in the presence of KOH. That is important. Very, very important. Let us now talk about nitriles and amides. How to prepare these two? We have to carry out the hydrolysis first. We will be getting an amide. So amide on hydrolysis will give us acid. So if I have an amide, directly I can treat it with H2O plus. We will be getting ethanoic acid over there. It's a very simple reaction. From Grignard reagent, how to prepare? We can treat it with CO2. Okay, treating it with CO2, we will be getting RCOOH. You can try out with a trick. We will get RCOOH over there. Let us now talk about, and here also we have to remember that this is ascent of series. Ascent of series, this is important. Next is from acyl halides and anhydrides. So there also we have to carry out the hydrolysis, right? Hydrolysis have to be carried out. In the presence of basic medium, we'll be getting the acid over here. Okay. Anhydride also on hydrolysis will give us benzoic acid, and here we have esters that will also give us the same. Next, esters, here you go. Esters also we have to carry out hydrolysis. We will be getting corresponding acid over there, or we can treat it with NaOH. We will get the sodium salt of carboxylic acid, and that on hydrolysis will give us acid. These are very easy process if we have esters, or if we have acyl halides, or if we have anhydrides. We can carry out nitriles, amides. We can carry out the process of hydrolysis. Okay, so let us now talk about physical properties. So when we talk about the physical properties of carboxylic acids, the first one is that they are having comparatively higher boiling point, comparatively higher melting point, and they are soluble in water because of ability to form hydrogen bonds. So that is important. Let us now talk about the various chemical reactions. The first one is formation of anhydride, which you have already studied. If we have two molecules, I'll take it over here, acidity we will do it in the end. If I have two carboxylic acids, like this, I have to treat it with P2O5. What is happening is that I have to remove an water molecule. So whatever is left, I will just join that. I will be getting an anhydride over there. So this reagent is important. Let us now talk about the next reaction. The next reaction is coming out to be esterification reaction. Esterification reaction. Now what is esterification reaction? If we have RCOOH that is treated with an alcohol, we will be getting esters over there. Plus H2O is obtained over there. This is esterification. Now let us talk about the next reaction. The next reaction is going to be reaction with PCl5. So if we have RCOOH treated with PCl5, we will be getting RCOCl plus POCl3 plus HCl. If I treat it with PCl3, I will be getting RCOCl again. And if I treat it with SOCl2 also, I will be getting RCOCl. Acyl chloride is obtained over there. Let us now see the reaction with ammonia. What is happening? We will be getting ammonium acetate first, right? NH3 have to be added, and after that we have to remove H2O we have to remove. We will be getting amide over there. Okay, so if I have benzoic acid also treated with ammonia, we will be getting ammonium benzoate. Remove a water molecule, we get benzamide. And here you can see, if I have dicarboxylic acid, both sides we have to add NH4 plus, remove 2 molecules of water, we get amide. On strong heating, they are going to eliminate a molecule of NH3 like this. NH3 is going to be removed out and we get a phthalimide here. Phthalimide synthesis. This is not Gabriel phthalimide synthesis, that is different. This is phthalimide synthesis. Let us now talk about reduction reaction. In reduction, we can use RCOOH have to be converted to RCH2OH. So we can use LiAlH4 or we can use B2H6. These are commonly used reagents. Next important reaction is decarboxylation, which you have already studied. What is decarboxylation? We have to remove a molecule of carbon dioxide, right, or carbon. So RCOONA is treated to give RH plus Na2CO3. What is the reagent that is used? The reagent that is used is NaOH in the presence of CaO. The ratio in which these two molecules are taken is important. They have to be taken in the ratio of 3:1. This is known as decarboxylation reaction. Next is halogenation. We have a name for this reaction, Haloalkanes reaction. In Haloalkanes reaction, what is happening? We have a carboxylic acid. There is a problem with the PDF. That is why it is jumbled like this. So you can see the reaction over here, halogenation reaction over here. RCH2COOH is treated with X2 in the presence of red phosphorus. So you have to add the halogen like this. This is what you're getting over here. Let us now talk about the electrophilic substitution reaction. Okay, so as you know, COOH is a meta-directing group and it's a deactivating group, right? But it does not undergo Friedel-Crafts reaction. What is the reason? Deactivating group and the catalyst aluminum chloride gets bonded to the carboxyl group. This is the reason why aldehydes, ketones and carboxylic acids do not react with Friedel-Crafts reaction. Remember the question I asked before? It was the same, right? It will react with the carbonyl carbon and it will form salt. That is the reason it will not react with Friedel-Crafts reaction, but it will carry out nitration, halogenation, sulfonation, etc. and we will be getting meta products over here. So this completes our chapter. We have one more topic left, that is our acidity concept. So I'll just go through that as well. Here you can see that first RCOOH on hydrolysis will give us H3O plus plus RCOO minus, right? So we can see that pKa is equal to minus log Ka. So we know these concepts, right? Strong acid pKa will be less than 1 and Ka will be high. If it is a moderate acid, then pK value will be 1 to 5. Weak acid means pK value is 5 to 15. Extremely weak acid means it is greater than 15. So how can you confirm that a carboxylic acid is acidic in nature? We can react it with a metal, it will release hydrogen gas. If I treat it with a base, we will get water over here. If I treat it with a salt, I will be getting H2O and CO2 over here. So all these will show that carboxylic acids are acidic in nature. But they are more acidic than phenol because phenoxide ion is comparatively lesser stable as compared to carboxylate ion. That is the important point. Next, effect of substituents that we have already studied, which has a dump dog. Withdrawing group will increases and donating group will decreases. Now here I have an order which I have given over here. I'll just put it in a box. Effect of groups in increasing the acidity order. This is the order. Okay, so if you have CF3, that is going to show the maximum acidity, and if you have phenyl groups, that is the minimum acidity. Now this is the decreasing order. This order is important. You have to read this order. It is given in NCERT. We have to by heart that order. It's very, very important. Now phenyl groups and vinyl groups increases the stability, thereby they are going to increase the acidity. This is also important. Phenyl and vinyl groups because of resonance. So these are some of the important points related to acidity. Most important, what is the effect of EWG and EDG? What is EWG and EDG? Electron withdrawing group and electron donating group. So let us now move on to the questions. Before we move to the questions, please keep an OMR or a paper ready. You can either keep an OMR or you can keep a paper ready so that you can attempt these questions in the form of a test. So let's start with the test. There are 20 questions. Certain questions have multiple correct answers as well. So in those questions, if you get all the correct answer, 2 answers will be correct for that questions, for every questions. So if you are attempting a question correctly, you can put a +1, +4, and if you are getting a negative wrong answer, then we have to put a -1. Okay, so you can put it like that, and finally you can get to know your score and comment your score below so that I can understand that you have seen this video till the end and have attended the test. So let us start with the first question. These are some of the questions from the Neetshala app. You can get more such questions. You can practice unlimited number of questions for every chapter from the Neetshala app. So let us see this question. An aldehyde which undergoes Cannizzaro reaction and reduces Schiff's reagent but does not reduce Felling's solution is. You have time, think and give the answer. And it's a very simple question. It does not reduce Felling's solution. It undergoes Cannizzaro reaction. It undergoes Cannizzaro reaction means it will not have an alpha hydrogen. Does not reduce Felling's solution means it will be C6H5CHO. The answer is option number C. Benedict's solution provides. You can answer now. I think this much time was enough for that question because Benedict's solution is very simple. You just have to know what is the ion present, and that is copper. Next question. Acetone reacts with iodine to form iodoform in the presence of. You need 3 seconds to answer this question. 1, 2 and 3. The answer is NaOH. These are direct questions. Now there are some questions for you to think. Question number 1, that you can do it as a question number 4. Okay, in your paper it should be question number 4. Addition of water to alkynes occurs in acidic medium in the presence of Hg2 plus ions as a catalyst. Which of the following products will be formed on addition of water to but1-wine under these conditions? Take a moment, write down the reaction once and you will get the answer. You can pause the video and give a trial. Yes, let us just do this once. It is given that the compound is but1-wine, so it is CH3CH C triple bond CH. This is treated with H2O in the presence of Hg2 plus. So we have to add water here. This side hydrogen, this side OH will come and this side hydrogen will come. Triple bond is broken, double bond is present. This bond will come over here. Right, this will come over here and the hydrogen will go to this carbon. And now what are we getting? We will get a C double bond O CH3. This is what we're getting. So the answer should be option number 2. Next question. Which of these compounds is most reactive towards nucleophilic addition reactions? Now, the reactivity towards nucleophilic addition reactions, you can pause and give a trial. Yes. So the explanation is, it is based on 2 factors. One is steric factors and the other is electronic factors. So here we can use steric factor to explain this, because if you are comparing the groups which are present on the left side and the right side of the carbonyl group, whichever is less sterically hindered, that will allow the nucleophile to attack easily. So here you can see this is a very bulky group, though this is a normal group. This is bulky, this is also bulky. This is bulky, this is also bulky. So anyway, these 2 cannot be the answer. These 3 cannot be the answer. So here we have a less bulky group and least bulky group. So the nucleophile can come and attack easily. So this is going to be the answer. Option 1 is the answer. Now let us move on to the next question. Question number 3. Correct order of increasing acidic strength is. You can pause the video and give your answer, and let's see the explanation. Here there is a simple method to do this. You don't have to think too much. Of course you have to think a little, that if we have a deactivating group or a withdrawing group will increases the acidity, right? So in that case, chloroacetic acid should be more acidic than acetic acid. So if you look at the options, you can see only option 3 has such a condition. So the answer should be option number 3. Now let us talk about the next question. Next question is a question from NCRT Exemplar, but that is a beyond NCRT question. Okay, so this question you can take it as a bonus. You can give 4 marks everyone. This reaction is known as Schotten-Bowman reaction, and the reaction is this. We have phenol treated with RCOCl or ARCOCl, that is known as benzoyl chloride, in the presence of pyridine. In the presence of pyridine, we will be getting this compound over here. So this is Schotten-Bowman reaction. So the answer should be option number 2. Phenol and benzoyl chloride in the presence of pyridine. Next question. Yeah, this you can give a trial. Reagent which do not react with both acetone and benzaldehyde. The answer should be option number 3, Fehling solution. Next one, Cannizzaro reaction is not given by. Very easy question. You have to check which compound has alpha hydrogen. That will not give us Cannizzaro reaction. So the answer should be option number 4. Let us now talk about the next question. Another very easy question. Which products is formed when the compound ArCHO is treated with concentrated KOH solution? Remember the main products. We have an alcohol and we have a sodium salt of carboxylic acid. So what should be the answer? We have an alcohol. It cannot be option number 1. It cannot be option number 3. It cannot be option number 4. So the answer should be option number 2. Let us now talk about question number 8. You can pause the video and you can attempt it. We have already discussed this type of question before. In the beginning of the lecture, I have discussed this question. I have discussed what is the type of isomerism that is shown and what is the product that is obtained. You can watch it again if you have a doubt in this section. It is keto-enol tautomerism. So it cannot be option number 1 and it cannot be option number 3. Either it can be 2 or 4. In that, which one is the answer? En and ol should be present at different positions, right? So it should be option number 4. Next question. CH3CHO is treated with CH3, MgBr and H2O. You have to get A. That is treated with H2SO4. Heat will give us B. And then you have to carry out hydroboration, oxidation. You will get C. You have to try out the reagents. What should be A? A should be this should be A. Dehydration should be carried out. So this should be B. And after that, you have to carry out hydroboration oxidation. So to this side, it will be H2 and here it will be, this bond should be broken and we will be getting OH over here, right? So A, we got it as this, and C we are getting as this. So it is positional isomerism, option number 2. Which is the most suitable reagent for the following conversions? What is happening? CH3 should be converted into OH. What should be the reagent that should be used over here? This is an acid, this is a ketone. How to do this conversion? It should be option number 3, iodoform test. Next, which of the compounds will give butanone on oxidation with alkaline KMnO4 solution? Pause the video and give the answer. What is the compound that we need? This is the compound that we need, right? Butanone. And we have to take which alcohol is needed. So this should be the alcohol. And what is that? It is butan-2-ol. Next question. In Clemmensen reduction, carbonyl compound is treated with. Very easy question. You just need 1 second for attempting it. Zinc amalgam in the presence of HCl. Next, which of these compounds does not undergo aldol condensation? Check which of these does not have an alpha hydrogen. It is option number 2. Right, option number 2 is correct. What about option number 4? Option number 4 is also correct. So it is a multiple correct answer question. It is a multiple correct answer question. Option 2 and 4 is correct. Next, this is also a multiple correct answer question. You have to treat the given molecule with NaOH. So what is happening? You will get sodium phenoxide. So this side will go with H and this side will go with ONA, and we will be getting sodium benzoate also. So 2 and 3 should be the answer. Question number 15. Which of the following conversions can be carried out by Clemmensen reduction? Pause the video and give a trial. Clemmensen reduction means you will have an aldehyde or ketone that is converted to a corresponding alkane, right? So first one is wrong. This one is also wrong. This can be correct, and this one also can be correct. So 2 and 4 should be the answer. Next, through which of the following reactions the number of carbon atoms can be increased in the chain? Increase in the chain means it is ascent of series. It is ascent of series, and I have taught you ascent of series in 2 places. What is that? Grignard reaction can be one of those, right? Grignard reaction can be one of those, and in aldol condensation also we have studied it is ascent of series. Next, benzophenone can be obtained by benzophenone. Benzophenone can be obtained by benzoyl chloride and diphenyl cadmium. That is possible. Even benzoyl chloride and benzene plus AlCl3, Friedel-Crafts acylation, that can also be used for this process. So with this we are concluding our chapter aldehydes, ketones and carboxylic acid. So in the next video lecture we will be discussing the chapter of amines. So see you again in the next lecture. Till then, goodbye and happy learning.